The Thermoelectric Heated Glove by me, Anga Joho. So the problem that inspired me to build this heated glove was the sufferer of having cold or freezing hands. Now, the sufferer can not only cause major injuries such as frostbite, frostnip, nerve damage, and joint pain, but it also affects millions across colder climates every single year. And so that's when I decided that there was definitely some flaws with modern day gloves, so I decided to build these heated gloves that are also energy efficient. And this is not a model, this is a working prototype. So my innovation, the Thermoelectric Heated Glove, will eradicate the problem of frostbite, frostnip, and the wastage of energy, as it is energy efficient and works off the heat of your hand, thermal energy of your hand. So my hypothesis was that if the thermoelectric glove is accurately built, then it should work off the heat of your hand, sufficiently keep your hands warm, whilst saving energy and heat. So the introduction. I'll be skipping that part for the purpose of the presentation. Background information. So for this science fair, there are three main things that I researched about for the background information: thermal energy, thermoelectricity and the thermoelectric generator, and the conductor tape that was used to distribute the heat around this glove. So what is thermal energy? Thermal energy is kinetic energy and potential energy combined. Kinetic energy it's in every object around us, and potential energy, it depends on the area of the object. For example, a single brick would have less potential energy than a stack of bricks. So with that thermal energy, it also proves that there's thermal energy in my hand, which will heat up this thermoelectric generator. And I'll be talking about that right now. So now transitioning onto thermoelectricity. Thermoelectricity is the application for two simple devices, one of them being the thermoelectric generator. So how this thermoelectric generator works is that something mildly hot is applied to one side, and something cold is applied to the other side. So my hand is going to be the heat source for this. It's going to be providing thermal energy for this thermoelectric generator to work. And the other side, the cold side, well, this side is going to be exposed to the colder climate while you're outside, thus producing some sort of current and heating up this conductor. Now for the conductor, I used copper as it is cheap, affordable, and it is the best conductor out there. So this is a model of the TEG. As you can see here, something hot is applied to one side, something cold is applied to the other, generates a current. And yes. So for my procedure, I will also be skipping this part for the sake of the presentation. Basically what I did for this procedure, for building this, was I got a woolen glove, I taped around some copper tape around it, and I attached two thermoelectric generators to both of the sides. So as you can see here, the insides of these thermoelectric generators will be close to my hand. So my hand will be touching these thermoelectric generators, producing some sort of current. And over this, so that for the sake of this presentation, so that you can see the inside, the mechanics of this glove, well, over this will go a winter glove, making this waterproof and efficient. So this is just some graphs, some observations that I found. The percentage of people who feel pain or discomfort having cold hands despite wearing gloves. 79.1% of people said yes. That is massive. As you can see here from this graph, 79.1% of people said yes. That means there's definitely some flaws in modern day gloves, and they can be improved. Thus leading to me building these heated gloves. And now these heated gloves, as I said in the start, they aren't only heated, but they're also energy efficient, unlike other heated gloves out there that work on batteries. The amount of people who have access to heated gloves. So because there's already heated gloves out there that work on batteries, they're very expensive. I'd say around, I've researched about them, they're around $140 to $120. This is going to be from the $40 to $60 range, and that is the average glove's price. thus making it cheap and affordable for the majority of the population that was surveyed. 95.3% of people said that they didn't have access to these heated gloves. The amount of people who have or who have known someone who has suffered from any cold-related injuries such as frostbite, frost, and joint pain, and any of those things along the line. 79.1% of people said no, 20.9% of people said yes. That is also pretty massive, as you can see that scale. 20.9% of people, that's 1 out of every 5 people. So this basically means that if my glove is sold or advertised to a mass amount of people out there, it could possibly influence the lives of millions, if not billions. So the conclusion. From the start, when I started this project, my hypothesis that I had stated ended up being true. I was correct. Though this glove isn't 100% as efficient as I wanted it to be, this is definitely a working model and a work in progress. This also proves that thermoelectric heating could possibly play a big role in the future of our climate, of our planet, as first of all, it reduces the wastage of batteries, energy, and that is huge because the current state of our planet, we are not in a good state. There's climate change, there's many other things, and this could possibly be one of those things that are positively contributing to that. So, said that, this is definitely not the prototype that I wanted it to be, but this is successful, it works, and that's all I have to say. So for the discussion, people of the age group around 40 to 60, I'd probably be selling this glove to them, or even really the majority of the population that has to work for longer hours in the cold. They could benefit from my innovation, and a lot of people that live in colder climates could benefit from my innovation. So something that I would do to get this product out there is the companies that I would call or ask help from would be North Face, Patagonia, Canada Goose, Eddie Bird. These are major winter wear companies, and as you can see here, this glove can be counted as winter wear. An efficient, energy efficient, heated winter wear. So the abstract, for the sake of this presentation, again I'm stating, I will not be reading out this abstract, but I will be including this whole presentation, this whole slide, and my lab report on the link. To end this off, all I want to say, I know I'm repeating a lot of things, but all I want to say is my glove is energy efficient, it works, this is a work in progress, but it proves that thermoelectric heating can work, and I would like to thank you all for listening to my presentation. Thank you.